Okay, let's solve this problem. It's to write the function distance that takes four int values or float values and that represent the points x1, y1, and x2, y2, and returns the distance between those points. Here's some examples, but this is actually quite familiar. What we need to do is basically implement the distance formula. We've seen this before. The square root of the difference of the x squared plus the difference of the y squared. I'll speak in a moment at the end of this video as to why that's true, but for now, we just need to implement that. Difference of the x squareds plus the difference of the y's, quantity squared. So let's go back here and let's copy this code and let's go into an editor and paste it. So now we have our test function and we have the function we're supposed to write. If we run this right now, it fails, of course, because the distance from 0, 0 to 3, 4 is supposed to be 5, and we, of course, have 42 because, of course, we do. We're just returning 42. Okay. So the distance formula said take the difference of the x's squared, so x2 minus x1, and I need to square that value. And in Python, the at 2 stars is exponentiation, so that is that value squared, plus the difference of the y squared, y2 minus y1 squared. And then I'm supposed to, let's go back here, that's the difference of the x's different than the y's, take the square root of the whole thing. So, oops, go back here. So I need to take the square root of this whole thing. First, I'm going to put it in parentheses, so I have the whole sum. So if this is the exponentiation operator, star star, square root is raising something to the 1/2. So this should work. And in fact, it does. So this is actually a valid answer. If you wanted a couple other things you could do, you could raise it to the 1/2 like that. And in Python 3, that'll work just fine as well if you prefer that. There's other things we could do to clean this up. For example, here in this example, we see that they use a and b. A is the difference in x's and b is the difference in y's. And that might make things clearer. So let's go ahead and do that here. We'll go here and we'll say that, hey, a is the difference in my x's, and b is the difference in my y's. Now, instead of this here, it's a squared plus b squared. And it's the square root of that we're returning. Okay? Still works. This is using some local variables. A and b are called local variables to make the solution a little clearer. Any of these solutions is just fine. Now, just a brief talking about the math. Why is the distance formula actually true? In case you're wondering, and if you're not, you can stop now. But here's x1, y1, here's x2, y2, and the distance is between those points. And these images make it clear what we're going to do. We're going to use the Pythagorean Theorem here because this side squared plus that side squared of this triangle will equal the hypotenuse squared. But the hypotenuse is exactly the distance we want. See? It's the distance from this point to that point. So this side squared, well, what is this side? It's actually the difference of this x and that x. It's x2 minus x1. And this side squared is the difference of the y's, y2 minus y1. So it's the difference of the x squared plus the difference of the y squared equals the hypotenuse squared, which is the distance squared. Take the square root and we're done. I hope that made some sense. Regardless, here's some code to solve the problem. And we are done.